In Lab 2, we will explore one of the 4 fundamental forces, gravity. Read the introductory section and pay particular attention to the scientific definition of force highlighted in the 3rd paragraph. Turn your attention to Part 1 at the bottom of Slide 1. You will figure out the quantity for the force of gravity by comparing the mass of an object to its weight. Turn to Slide 3 and complete the Before You Begin section. Now go on to the bottom of that slide and do the quick review, which continues on to Slide 3. Read the information in the box on the bottom of Slide 3. Notice that weight is affected by both the mass of the planet or celestial body the object being measured is located on or near, and even more importantly, any distance separating the two. Read the information in the box at the top of Slide 4 about the differences between measuring mass and weight. We'll now move on to the first part of the lab where you will determine the relationship between the mass of an object in kilograms and its weight in newtons. I will measure the mass and the weight of the first object and provide you with the data for the remaining 4. You can then do the calculations on your own. Fill in the names of the objects to be measured in the first column of the data table on the bottom of Slide 4. Pause the video as needed. Now we measure the mass of the tape dispenser. That mass is 462.13 grams. That number goes in the mass in grams column. To convert mass in grams to kilograms, we use the mnemonic, King Henry died by drinking chocolate milk, and figure out the decimal needs to be moved 3 places to the left. The column heading tells us to round to 2 decimal places. Now I measure the weight of the tape dispenser using the force sensor on the LabQuest. You'll notice that the way this works is that the dispenser has to hang so that gravity has a chance to have an effect on its weight. So I'm going to call this reading 4.629 newtons. Add that number to the data table. Substituting the weight in newtons and the mass in kilograms into the final column, we can see that the relationship shows the weight is the mass in kilograms multiplied by roughly 10. Now copy the remaining masses and weights into your data table and fill in the remaining spaces. Now go ahead and complete the questions on Slides 5 and 6. Turn now to Slide 7. During the second part of this lab, you will apply your knowledge of the effect of a planet's or celestial body's mass on the gravitational pull it exerts on objects and therefore its effect on their weight. Read the introduction to Part 2 on Slide 7. Read and complete the prediction for Part 2. If the number in the middle column is greater than 1.0, it means that the celestial body has a mass that many times Earth's mass and a gravitational pull that is that many times greater than Earth's gravitational pull. In order to see whether you could jump higher on those other celestial bodies than on Earth, we first have to see how high you can jump on Earth. In order to do that, you need to make a mark on a piece of paper where your arm reaches before jumping. Now with the pen in my hand in the same position, I'm going to jump and make a mark at the top of my jump. I'm going to do this 2 more times so that I have a total of 3 measurements. I'm now going to take that paper down and measure the distance between my bottom mark and each of the 3 and enter it into the data table. These are my numbers. You may use these numbers, or you may do the jumping for yourself and use your own numbers. The next step is to calculate the mean of the jump height values and enter it into the table. Then, copy that mean value into the first box in every row of the bottom data table and multiply it by the conversion factor in the middle column. This conversion factor is the ratio of Earth's mass to the other planet or body's mass. If it is a number less than 1, it means that Earth's mass is less than the mass of the other planet or body. If the value you calculate correctly matches your prediction from slide 7, type a Y into that column. If not, type an N. Now go ahead and finish the questions on slides 9 and 10.